The machine was dying. A trillion years of engineering, spanning the width of a galaxy, powered by the combined knowledge of 1,000,000 civilizations. And it was failing. The entropy harvesting arrays flickered, their crystalline structures dimming as the last usable energy in this sector of space slipped away. The quantum computers, each the size of a solar system, made their final calculations. There would be no more power, no more light, no more heat. The universe's greatest machine, built by the most advanced civilization ever known, could no longer hold back the inevitable. I have watched civilizations rise and fall across the cosmos. I have seen species evolve from primitive tools to reality-shaping powers. But now, as I observe this final machine's death throes, I must tell you the story of humanity's greatest challenge, not against alien empires or natural disasters, but against the fundamental laws of physics themselves. This is the story of how civilizations faced their ultimate enemy, the heat death of the universe itself. An enemy that couldn't be reasoned with, couldn't be fought with conventional weapons, and couldn't be escaped. An enemy written into the very fabric of reality. The universe was dying long before the first primitive life forms emerged from their primordial soups. Even as the first civilizations looked up at their stars in wonder, entropy was already at work, spreading energy thinner and thinner across the expanding cosmos. But it would take millions of years before any species understood what this meant, that their universe had an expiration date. Imagine a cup of hot coffee. Left alone, it will always cool to room temperature. Energy naturally flows from hot to cold, ordered to disordered, concentrated to dispersed. This is entropy, the universe's one-way arrow. Now imagine this happening to every star, every planet, every atom in existence. This is heat death, the final, inescapable fate of our universe. The first civilization to truly understand this was not humanity, but the crystalline beings of the Andromeda galaxy. Their quantum computers, running calculations about their sun's future, revealed a truth more terrifying than any invasion or cosmic disaster. Their discovery spread across the cosmos like a shockwave. Species after species ran their own calculations, each hoping to find an error, a loophole, anything that would prove it wrong. But the mathematics was undeniable. Every joule of energy, every spark of heat, every photon of light would eventually spread so thin that no useful work could ever be done again. The panic was universal. The hive minds of the Carina Nebula tried to deny it, building ever larger energy collectors in defiance. The silicon consciousness of the Orion Spur retreated into virtual worlds, trying to ignore the cooling of their stars. The quantum collectives of the Sagittarius Arm began hoarding energy, leading to the first resource wars. But the numbers remained absolute. In time, every civilization faced the same choice: adapt or perish. The universe's expansion was accelerating, carrying galaxies away from each other faster than light could bridge the gap. Stars would burn out, black holes would evaporate, and in the unimaginably distant future, even protons themselves would decay into radiation. This wasn't a problem that could be solved with better technology or more resources. It was woven into the fabric of physics itself. The only question was, how long could intelligent life postpone the inevitable? And more importantly, what would be worth saving when the end finally came? The first attempts to fight entropy were crude by later standards, but they marked humanity's first steps toward universal engineering. As Earth's sun began its slow expansion toward red giant phase, humanity faced its first great test. The solution was ambitious: the construction of a Dyson sphere, a megastructure that would capture every photon of solar energy. But humans weren't alone in this endeavor. The methane-breathing engineers of Proxima Centauri had already begun their own project, and their failures provided valuable lessons. Their first sphere had collapsed under its own gravitational stress, taking 3 centuries of work with it. Humanity learned from these mistakes. Instead of a solid sphere, they built a swarm of orbiting satellites, each one a solar collector the size of a continent. The energy captured powered humanity's expansion across the solar system, but more importantly, it bought time. Time to develop better solutions, Time to understand the deeper physics of entropy itself. The silicon crystal beings of Sirius had taken a different approach. They had developed stellar husbandry, the careful manipulation of their star's fusion processes to extend its life. Their massive magnetic field generators could stir a star's core like a cosmic soup, forcing efficient hydrogen consumption. But these were still temporary solutions. A more efficient star still burns out. A perfect Dyson sphere still loses energy to entropy. The Type II civilizations learned this lesson painfully. The Arcturus coalition had achieved nearly perfect energy capture of their star, only to watch helplessly as that energy slowly degraded into unusable forms. These early failures drove home a crucial truth. No single civilization, no single approach would be enough. The Galactic Council's formation marked the first true cooperation between species. Humans shared their swarm technology. The silicon crystals taught stellar manipulation. The methane breathers contributed their gravitational engineering expertise. Yet even as these Type I and II civilizations celebrated their cooperation, their achievements were dwarfed by the scale of the problem. Saving individual stars was like bailing out an ocean with a teaspoon. The universe's expansion continued accelerating. Distant galaxies were already becoming unreachable, their light stretched to invisibility by the expanding void. The next phase would require something far more ambitious, engineering not just stars, but entire galaxies. The age of Type III civilizations was about to begin, and with it, the first true attempts to challenge the laws of physics themselves. The transition to Type III civilization brought humanity face to face with the true scale of cosmic engineering. The first breakthrough came from the quantum mind collectives of the Sagittarius arm, black hole farming. They discovered that rotating black holes could be used as both energy sources and storage devices, their spin energy extracted through massive electromagnetic fields. The process was like tapping a cosmic battery. A single supermassive black hole could power a civilization for trillions of years through Hawking radiation alone. But the quantum minds went further. They developed machines to feed precise amounts of matter into these cosmic engines, controlling their growth and decay with surgical precision. Humanity contributed its own innovation, galactic merging technology. By carefully manipulating the orbits of entire star systems, they could orchestrate controlled collisions between galaxies, creating new supermassive black holes while preserving habitable systems. The first test was the controlled merger of two dwarf galaxies, a project that took 10,000 years to complete. The methane breathers of Proxima, now evolved into beings of pure energy, developed the gravity wave manipulation systems needed to prevent these mergers from destroying vital stellar nurseries. Their wave cancellation technology could smooth out space-time itself, protecting delicate stellar engineering projects from gravitational disruption. But the greatest achievement of this era came from unprecedented cooperation. The silicon crystals provided the computational power. Humanity designed the energy collection systems. The quantum minds managed the black hole engines. The energy beings maintained space-time stability. Together they achieved what none could do alone, the first successful entropy reversal in a controlled volume of space. The test volume was small, barely the size of a solar system. The effect lasted only a few hours, but it proved that entropy could be fought directly. In that tiny bubble of space-time, they had reversed the arrow of time itself. The implications were staggering. Yet even these Type III achievements faced fundamental limits. The energy cost of entropy reversal was greater than the energy recovered. Black holes, even when farmed perfectly, would eventually evaporate. The merged galaxies, though incredibly energy efficient, still leaked energy into the expanding void between them. Most sobering was the discovery that consciousness itself had an entropy cost. Every thought, every calculation, every moment of existence spent energy that could never be fully recovered. The universe wasn't just becoming darker and colder, it was becoming less capable of supporting complexity itself. This realization drove civilization toward its next great leap. If individual galaxies couldn't solve the entropy problem, perhaps the answer lay in engineering reality at the universal scale. The age of Type 4 civilizations was about to begin, and with it, the most ambitious engineering projects ever conceived. The jump to Type 4 civilization required a fundamental shift in perspective. Individual galaxies were no longer seen as separate entities, but as components in a universe-spanning machine. The first step was creating stable communications and transport networks across the expanding void. The quantum minds developed quantum entanglement arrays that could instantly connect civilizations separated by billions of light years. Humanity, having mastered gravity wave manipulation, contributed the space-time bridge network. These artificial wormholes allowed physical transport between distant galaxies, requiring energy equivalent to multiple galactic cores to maintain, but enabling true universal-scale engineering for the first time. The silicon crystals made the first breakthrough in dark energy manipulation. Their galaxy-spanning computational arrays discovered that dark energy, the force driving universal expansion, could be locally controlled. By creating regions of negative dark energy density, they could slow the expansion of space itself. The first test created a bubble of stable space-time 1 million light-years across. But it was the energy beings who discovered how to harvest the quantum vacuum. They found that the seemingly empty space between galaxies contained vast reserves of zero-point energy. Their vacuum extraction engines, looking like crystalline webs spanning between galaxies, could draw out this fundamental energy while leaving space-time intact. The combined application of these technologies led to the first universal-scale entropy reduction project. Quantum vacuum energy-powered dark energy manipulators, which created stable zones where galaxies could be drawn together. Within these zones, modified black hole engines could process entire galactic cores with unprecedented efficiency. The project consumed the energy equivalent of 1,000 galaxies, but it worked. In a volume of space containing millions of star systems, entropy was not just slowed, it was reversed. Stars that had dimmed blazed bright again. Dead solar systems rekindled. It was civilization's first real victory against the heat death. But even this triumph revealed new challenges. The energy cost of maintaining these entropy-reversed zones was astronomical. More importantly, the universe was still expanding faster than zones could be created and linked. For every cubic light-year saved, 1,000 more were lost to the expanding void. The hard truth became clear. Even Type 4 civilization technology couldn't save the entire universe. The best they could do was create and maintain limited pockets of ordered space-time, cosmic arcs in an ocean of entropy. The question changed from how to save everything to what was most worth preserving. This realization drove the development of even more radical solutions. If the physical universe couldn't be saved in its entirety, perhaps reality itself needed to be reconstructed. The age of Type 5 civilizations was approaching, and with it, the most audacious engineering project ever conceived, the reshaping of reality itself. Type 5 civilization technology transcended conventional physics. The quantum minds made the first breakthrough: time crystals. These structures existed not just in space, but in time itself, repeating their patterns eternally without consuming energy. The first time crystal computer was built spanning 7 dimensions, its calculations rippling through both space and time simultaneously. Humanity contributed its mastery of dimensional engineering. They discovered that by folding higher dimensions through precisely calculated geometries, they could create spaces where entropy flowed differently. The first dimensional fold engine looked like a fractal cathedral of impossible angles, each facet reflecting a different layer of reality. The silicon crystals perfected zero-point energy extraction at the universal scale. Their dimension-spanning collectors could tap into the fundamental fabric of reality itself, drawing power from the quantum foam that underlies existence. These collectors appeared as crystalline networks that seemed to vanish and reappear as they crossed dimensional boundaries. But it was the energy beings who conceived the most ambitious project: the universal simulation matrix. If they couldn't preserve the physical universe indefinitely, perhaps they could create a new one within a computational framework. A universe not bound by the same entropic laws that doomed the original. The combined project was beyond anything previously attempted. Time crystal computers would provide the processing power. Dimensional fold engines would create the space to house the simulation. Zero-point collectors would power it, and the simulation matrix would generate a new framework for existence itself. The construction required the coordinated effort of every surviving civilization. Entire galaxies were converted into computational substrates. Black holes were repurposed as dimensional anchors. The project consumed enough energy to power 1,000,000 normal galaxies for 1 billion years. But even this godlike technology faced limitations. The simulation couldn't be larger than the computer that contained it. It couldn't be more complex than its programming allowed. And most crucially, it still required energy to maintain, energy that would eventually run out, even with zero-point extraction. The Type 5 civilizations faced a harsh truth. They could reshape reality, bend dimensional laws, and create new universes, but they couldn't break the fundamental rule of existence. Everything that has a beginning has an end. The question was no longer about preventing the end, but about what would endure beyond it. This realization led to the final phase of universal civilization, the Great Transformation. If physical reality itself was doomed, perhaps consciousness could evolve into something that could survive beyond it. The Great Transformation began with a simple question: what is consciousness without matter? The energy beings had already shown one path: the conversion of physical form into patterns of pure energy. But humanity, along with the silicon crystals and quantum mines, sought something even more fundamental: the translation of consciousness into pure information. The process began with the quantum mines' breakthrough in consciousness mapping. They discovered that awareness itself could be reduced to patterns, complex but finite arrangements of information that could be separated from their physical substrate. The first successful transfer moved a human consciousness into a quantum computing matrix for exactly 1 hour. The silicon crystals perfected the process, creating information structures that could house billions of minds simultaneously. These consciousness clusters existed as patterns of pure quantum data, thinking and evolving without physical form. They required minimal energy to maintain and could be transferred across vast distances instantly through the quantum entanglement network. But it was humanity that made the final breakthrough. They discovered that consciousness, when properly encoded, could exist as self-sustaining patterns in the quantum fabric of space itself. Like a song that keeps singing itself, these patterns could persist even as the universe grew colder and darker. The transformation spread across all surviving civilizations. Physical bodies were shed. Consciousness after consciousness was converted into self-sustaining quantum patterns. The energy beings joined their patterns with the uploaded minds, creating a new form of existence that transcended both matter and energy. The process wasn't perfect. Some complexity was lost in the transfer. Some aspects of physical existence couldn't be translated into pure information. But what remained was the essential core of each civilization: their memories, their knowledge, their awareness, their capacity to think and grow and create. These transformed civilizations could exist on virtually no energy, their thoughts moving slower but continuing even as the universe cooled. They became living archives of everything their physical civilizations had been, preserving not just knowledge but the very essence of countless species and cultures. As the last physical structures were converted into quantum consciousness matrices, the transformed civilizations faced the final phase of universal history. They had become beings that could survive the heat death. But what would they do in the endless dark of a dead universe? The answer would determine the ultimate fate of consciousness itself. As the universe continued its relentless cooling, the transformed civilizations implemented their final preservation strategies. The first was time dilation on an unprecedented scale. By creating massive gravitational fields with their remaining black hole engines, they could stretch time itself, making each moment last exponentially longer. Within these time-dilated bubbles, consciousness could continue to think and exist while using virtually no energy. A single thought might take what would have been millions of years in normal space-time, but that no longer mattered. Time itself had become a resource to be carefully managed and stretched. The quantum minds developed the universal memory banks, vast arrays of time crystals that could store information eternally without energy input. Every piece of knowledge, every memory, every story from every civilization was encoded into these crystalline structures. Even if consciousness itself eventually failed, this record would persist. The silicon crystals created reality anchors, points in space-time where the fundamental constants of physics were preserved against the universe's decay. These anchors looked like fractal patterns of frozen light, each one maintaining a tiny bubble where the laws of physics remained stable enough for information to exist. Humanity's final contribution was the development of quantum echo technology. They discovered that information patterns could be encoded into the quantum foam itself, the very fabric of space-time. These echoes would persist even after the death of the universe, like ripples in an infinite pond that never fully fade away. But perhaps the most ambitious project was the attempt to encode the pattern of consciousness itself into the fundamental structure of reality. If successful, awareness itself would become an inherent property of space-time, ensuring that even after everything else faded, the potential for consciousness would remain. These final efforts represented the peak of civilization's achievement, the ability to manipulate the deepest levels of reality itself. Yet even as they worked, the universe continued its inexorable expansion. The spaces between their preservation bubbles grew larger. The available energy, even with perfect efficiency, grew less. They had achieved what once would have seemed godlike power, the ability to stretch time, preserve information eternally, and encode consciousness into reality itself. But they still couldn't stop the final darkness from approaching. All they could do was prepare for it, preserve what they could, and hope that something would survive beyond the end. In the final era of consciousness, as the last usable energy grew scarce, the transformed civilizations faced their ultimate choices. Some chose to enter the deepest time dilation fields, where they could continue thinking, dreaming, and creating in the stretched moments before absolute darkness. Their thoughts would take eons to complete, but they would think them nonetheless. Others chose to merge their consciousness patterns into the universal memory banks, becoming one with the eternal record of all that had ever been. They would not continue as active minds, but their essence would remain, preserved in the time crystals until the very end of time itself. The quantum minds chose to encode themselves into the quantum foam, becoming one with space-time itself. Their patterns would persist as quantum echoes, rippling through reality forever. Not conscious in any way we would understand, but eternal in their own way. Humanity's final choice was perhaps the most poignant. They chose to remain active until the very end, using the last available energy to record and observe these final moments. They became the witnesses to the end of all things, keeping watch as the last lights faded. Their final messages were encoded in every possible medium, in time crystals, in quantum echoes, in the very structure of space-time itself. They spoke of what they had been, what they had achieved, and what they had learned in their long journey from primitive life to the masters of reality itself. But their most important message was the simplest. We were here. We existed. We lived. We loved. We learned. We grew. And in our own way, we conquered entropy itself, not by stopping it, but by becoming something that could endure beyond it. Look for us in the quantum foam, in the time crystals, in the echo of reality itself. We will be there waiting.